Hello, I'm ETarte, math teacher. This is a solution video for my math challenge, Your Basic Parabola. In that challenge, I presented this parabola. It has the equation y equals x squared, and it has a focus and a directrix. Its focus is this point 0, 1/4, that's 1/4 unit above the origin on the y-axis. Its directrix is this horizontal line 1/4 of a unit below the x-axis, and the thing about the focus and the directrix is, by definition, every point on the parabola is equidistant from its focus and its directrix. So as I've shown here, if this point P represents any point on the parabola, this distance to the focus is the same length as this distance to the directrix. And the challenge is to prove that. Well, there is one situation in which the distance from the point on the parabola to the focus is vertical. There are two situations where that distance is horizontal, and otherwise it's slanted, as shown here. The situation where it's vertical is the vertex. The distance from the vertex to the focus is 1/4 of a unit. Distance from the vertex to the directrix is also 1/4 of a unit. So that point is equidistant from the focus and the directrix. We have two situations where the distance from a point on the parabola to the focus is horizontal. One of them is directly to the right of the focus. The other one is directly to the left of the focus. The coordinates of these 2 points are 1/2, 1/4. That's the one on the right. And the one on the left is -1/2, 1/4. Notice that 1/2 squared is 1/4. When you square -1/2, you also get 1/4. This point is 1/2 an inch away from the focus, and it is also 1/2 an inch away from the directrix. And the same is true of this point. So that's the case where the distance from the point on the parabola to the focus is horizontal. Otherwise, the distance is slanted, and I show that here. I show an example with these red segments. So in the main part of my explanation, I need to show that the distance PF equals the distance PD. In order to show that, I have formed a right triangle by this segment from F to G. And I'm calling the coordinates of P A squared, since it's a point on the parabola having the equation y equals x squared. This horizontal distance from F to G is the absolute value of A. The distance from F to G is a little less than A squared. It is A squared minus 1/4. We're going to use these distances FG and PG to find the distance from P to F. We will be using the Pythagorean equation about the three side lengths of a right triangle. A squared plus B squared equals C squared. In this case, FG squared plus PG squared equals PF squared. That is the absolute value of A squared plus A squared minus 1/4 squared. We're going to evaluate that and simplify it. When we do the squaring, we get A squared plus a to the fourth power minus 1/2 a squared plus 1/16. And we combine these two like terms, the positive a squared and the minus 1/2 a squared, to the middle term plus 1/2 a squared. So we have a to the fourth power plus 1/2 a squared plus 1/16. That is a perfect square trinomial. It can be factored into a squared plus 1/4 squared. And so a squared plus 1/4 squared equals pf squared. And that means that pf equals a squared plus 1/4. But if we look at the vertical segment PD, we see also that it is a squared plus this 1/4 at the bottom. And so we find that PF equals PD, and that was what we were supposed to prove, that the distance from P to the focus F is the same as the distance from P to the directrix. Now, what I have not included in this explanation is the situation where the point P is down here close to the vertex, between the vertex and one of these two points that are directly horizontal to the focus. I leave that part of the proof to you. It's very similar to what you see here. So that concludes my solution to this challenge, your basic parabola. Thank you for watching.